Hello friends, welcome to my channel. In today's video, we will discuss about queue management system. So queue management system is a very important module that is used to make the process asynchronized so that the user doesn't have to wait for anything. The moment there is a request, it is put into a queue and then that queue is served by some subscribers. Just like you can take an example of Zomato or any such type of application in which there is continuous delivery of data, just like the rider's location. So every 1 second it is refreshed, and again there is a customer who is checking all the details, who is tracking the rider's data. So again, these type of data again for per second it is pushed onto the database. And again, I'm not talking about one rider. There will be n riders, n customers. Every customer is tracking his own rider. So at particular time there is lot of data that is published. So just to make the process asynchronous, this queue management concept, again, in all the three different types of cloud providers like Azure, AWS and GCP, so they all provide this queue management service in different name, under different names, like simple queue management in case of AWS. Then in case of Azure we have Event Hub. In case of GCP we have PubSub. So there is a publisher, there is a subscriber, and there is a queue. So in the queue we have different topics, and just like if I talk about Zomato rider or Zomato, so there will be a section where we are tracking the ride. There will be a section topic for your orders. There will be a section for promotions. So all those different topics, and then based upon the subscriber, it subscribes to a particular topic, and then there is no restriction. Publisher keeps pushing the data in the queue, and subscriber, as and when they are available, they will start fetching. So we have fully managed global serverless. So this, again, it is not an exactly a replacement of database, but it acts as a storage. So it's a real-time memory service that allowed to send and receive message between producer and consumer. Message can be anything, just like I talked about the stream of data, where every second the rider is sending the details, every second the customer is fetching the details. Again, this will be attached to a particular topic. So there will be number of topics, and based upon the subscription to which topic a particular subscriber is subscribed, so he will be getting the details. So there will be no wait time. The moment there is a request, it will be put, and then it will be sent to a queue. Publisher application creates or sends message. Just I talked about the rider, he sends his details, and subscriber, what he does, he receives, he subscribes to that message. Now there is, because again lot of data is being transmitted, lot of data is being created every second. So again we will have a limitation of the storage, because again we are not talking about a full-fledged SQL server. We are not talking about a MySQL server. We are not talking about any NoSQL. We are talking about an intermediate queue. So again, queue also act as a storage device. So there should be some limitation, so that beyond that, that particular message, that particular data is not available. So we have the option, so we can set how much time this needs to be retained. And again, the good thing is for this queue management is 1 million message per second it can handle. So that is the good thing. that we cannot handle in case of SQL, as the throughput of queue, we are talking about PubSub, there is an queue management system called Kafka. So these queues are very helpful in whenever we are going to manage continuous streaming data. And again, it is not a replacement of database, but it supports the database, because in database at one particular time you cannot continuously, so there is a limitation per second how much data can be inserted into the database, and it is far less than what we just discussed. At least once delivery order is not maintained, one to many, many to one, many to many, all those communication, one publisher many subscriber, many publisher many subscribers, so all those relationship can be managed. Again, I talked about different topics. So for a queue management, it is very important to segregate the data based upon the different topics. So it should not be, everything should be connected to one topic in the queue. So in order to manage the data properly, the topic distribution should be managed in such a way that subscriber can subscribe to the topic of interest, and then based upon the subscription he will be getting the data. So this is basically queue management. It is again similar in terms of asynchronous data operations, plus in GCP it is maintained using PubSub. So there will be a publisher, there will be a subscriber, and between publisher and subscriber there will be a queue. In queue there will be different topics. The publisher sends the message continuously, delivers the message. Those messages are stored in queue under different buckets. Subscriber subscribes those topics based upon the different topics. So basically this will be an implementation, and again after a certain period of time all the data accumulated is being stored in a big database, and it can be any database: SQL, NoSQL, SQL Server, MySQL, Postgres, or in terms of NoSQL, if you're talking about, there will be Bigtable, Cosmos DB, DynamoDB, whatever database is there, you can store it. So this was all about PubSub relationship, and again setting up it is very simple. You just need to create the publisher, you just need to create the queue, and then create the publisher and the data. If you like this video, please like, share and subscribe, and thank you for watching this video.